A cart moves in a horizontal line with a constant speed v. Rain starts to fall at a rate of sigma kilogram per second. This means that 1 second sigma kilogram have fallen on the cart. The cart must keep moving at a constant speed. Determine the force that must be applied on the cart. Net force is equals to rate of change of momentum. And change in momentum equals to change in mass times velocity. Since the velocity is constant, we have v delta m over delta t. And the rate of mass change is equals to sigma, so v times sigma. Gravel falls vertically on a conveyor belt at a rate of sigma kilogram per second as shown in diagram. A very popular exam question. A. Determine the force that must be applied on the belt to keep it moving at a constant speed. This is very similar to previous slide. The force is a net force, that is rate of change of momentum. And rate of change of momentum is change in mass times velocity over change in time. As the velocity is constant, we take it out delta m over delta t. And the rate of mass change is sigma, so v times sigma. And AII, the power that must be supplied by the motor turning the belt. The power can be written as force times velocity. And the force is velocity times sigma from the AI, and we can find sigma times velocity squared. AII, the rate at which kinetic energy of the gravel is changing. In 1 second, mass on the belt increased by sigma, so we utilize kinetic energy formula. So the rate of kinetic energy increase is change in kinetic energy over change in time. Change in kinetic energy equals to 1 over 2 mv squared over delta t. Velocity is constant and the 1 over 2 is constant. So we have 1 over 2 v squared delta m over delta t. And the delta m over delta t is a sigma. So we have 1 over 2 sigma v squared. B. Explain why the answer to AII and AIII are different. From II, power supplied by the motor equals to sigma v squared. And the rate at which kinetic energy changing is half. Explain why the answer to AII and AII are different. The rate of the increase in kinetic energy is less than the power supplied. This is because the power supplied by the motor goes to increase the kinetic energy of the gravel and also provide energy needed to accelerate the gravel from 0 to speed v in a short interval time when the gravel slides on the belt before achieving the constant final speed. Therefore, the rate at which kinetic energy changes the half of the power supplied by motor. 0.5 kilogram ball is dropped from rest above the hot floor. When it reaches the floor, it has a velocity of 4 meters per second. The ball then bounces vertically upward. Is a graph of velocity against time for a ball. A. Find magnitude of the momentum change of the ball during the bounce. We choose downward as a positive direction, that is 4 meters per second, and after bounce, reverse direction, and that is minus 2 meters per second. So the change in momentum is final momentum minus the initial momentum, which is mv minus mu. we take out the common factor mass, which gives us final velocity minus initial velocity. We plug in the values. 0.50 times final velocity is minus 2 minus initial velocity is 4. So that gives us minus 3.0 Newton second. Minus sign here indicates the direction. So as momentum is a vector quantity. B. The ball stays in contact with the floor for 0.15 seconds. What average force did the floor exert on the ball? The question is actually asking the average force the floor exerts on a ball. So before that, we need to find the net force. The force acting on the ball is the weight and reaction force. So the net force equals to reaction minus the weight. And weight is mg. Net force equals to rate of change of momentum. Change in momentum of the ball is 3 from previous slide. And change in time is 0.15. That is 20 Newton. This is also force that produces the change in momentum. Of course, that's the rate of change of momentum. The question asking the average force did the floor exert on the ball, it actually asking the reaction force. So reaction force equals to net force plus mg. So net force is 20 Newton plus 0.5 times 9.81. That gives us 25 Newton. Moving body of mass m collide with a stationary body of double the mass and stick to it. Calculate the fraction of the original kinetic energy that is lost. The first bodies move forward and collide, and then they move together, right? Initial kinetic energy of the system equals to 1/2 mu squared, as the second mass is stationary. Using conservation of momentum, m times u plus 2 times m times 0, as the second mass is stationary, and they stick together, so m plus 2m times v. So we can find the velocity as after they hitched. So mu equals to 3m v. That gives us mu over 3m. M's cancel out, and velocity is equals to u over 3. Total kinetic energy after the collision is 1/2. Total mass is 3m, and velocity after collision is u over 3 squared. We get 1/6 mu squared. So the lost kinetic energy equals to initial kinetic energy minus the final kinetic energy. That is 1/mu squared minus 1/6 mu squared. That gives us 1/3 mu squared. So the question asking the fraction of the original kinetic energy that is lost. That is the lost kinetic energy divided by initial kinetic energy. That is 1/3 mu squared, which is the lost kinetic energy divided by initial kinetic energy, and that gives us 2/3, or 67% of the original energy that is lost, and probably converted into a thermal energy and sound energy.